So in manual input, let's say you adjust it to 0.35, then the expected result will be 51 MPa at 28 days. So of course it is not complying to our requirement, which is C60, but applying for the automated option, now we find out that in 0.31 water cement ratio we will get the 60 megapascal, and we can also try it here. So hello and welcome back to another video presentation, and in today's video I'll be showing you how to use our concrete mix design optimizer. And the main feature here is this chart, where I'll be showing you how to estimate the strength using two options. One is to automate it, so precisely you will have the correct water cement ratio with the corresponding strength, wherein previously calculated from here required average strength. So automatically, if you choose this option, it will provide you the water cement ratio, wherein it will give you the corresponding compressive strength at 28 days. And another option that it will provide us is the manual option for the water cement ratio, where you can adjust and still find out what will be the corresponding strength. So what does it give you? So it provides us a precision, not only that, but to save our time. Instead of guessing, instead of going through this table from the ACI, which is also good. I'm not saying we don't have to look at this table anymore, but it saves our time. Instead of going through this, or instead of going through your historical data and wondering what will be the water cement ratio for this particular mix design, so it helps you create your mix design more precisely. So therefore you can provide a mix design to your contractors or to your sales team in a much shorter period of time. So let me just explain to you again that this chart here came from, or reference to, this table also from ACI for the high strength and for the normal strength. So I took three water cement ratios, 0.25, 0.42 and 0.79 out of those table. This is the table for that, and I created this chart with this equation. I apply it here. So assuming that everything is according to the standard, let's say your materials, your production according to standard ASTM and ACI and all, so you should be getting the 60 megapascal in this example. And the good thing here is that you can change this also based on your own data, so it will represent your own degree of quality control and the performance of your technical team. And so simply you will be more confident to create your mix design. That's what I'm saying to other people who are asking me. So wherever you are and wherever you will go, you should always establish your own chart for this compressive strength and water cement ratio. You cannot apply what you learned or what you have in X country to another country. So you need to always establish your own table for water cement ratio and compressive strength. I hope you understand the value of this template, and I'm sharing it to you because I already been using it for more than 15 years and I find it very effective. The idea is just to play on the margin. It's not a rocket science. So let me just explain to you further. Let's say, Cesar, my result is always plus 3 MPa from your template that you provide me. So it's very easy. We don't need to complicate that matter. Simply add 3 MPa in this formula. So every time you use this formula, it's more than 3 MPa. So again, it will equate to whatever you're experiencing in your plant in your own degree of quality control. So just let me go back to the previous formula. So I hope you understand how I use this template. So let me do an example so that you can appreciate more how to use this template. So let's say I have a C50 OPC required concrete mix. The nominal maximum size of aggregate is 19, 175 plus or minus 25 slump. Specified cylinder strength is 50 MPa with equivalent cube strength of 60. I add this value of cube strength since in Middle East we are also using cube. So if you have a standard deviation, you can always write down your standard deviation. But if you don't have, it's okay also. Just keep it empty. So the calculated required average cylinder strength is 60 megapascal, or in other words, target mean strength 60 MPa. So again, our specified strength is C50, and we are required to achieve 60 MPa. So the margin is 10 megapascal from 50 to 60. So our maximum water cement ratio in this example, we are required to use 0.35 and the minimum cement content 400. So let us start with those values. So 400 minimum, so let us put 400 here, and the water cement ratio 0.35 maximum. So in manual input, let's say you adjust it to 0.35, then the expected result will be 51 MPa at 28 days. So of course it is not complying to our requirement, which is C60, but applying for the automated option, now we find out that in 0.31 water cement ratio we will get the 60 megapascal, and we can also try it here. If I will adjust to 0.31, if I will get the same. So in 0.31 I will get 61.1, not exactly, but sure enough it's near value, since these are running through automatic calculation. So if you need less margin by increasing water cement ratio, then you will have reduced target strength. Now it becomes 55.7. So for the sake of this presentation, let us use the automatic option 0.31. So water cement ratio here is 0.31, and the water content as per ACI is 138. And as I have explained to you before in the earlier presentation, so the reason for increasing the water here is because the voids of sand is probably high, so I have to increase it. So the calculated water will be 0.31 by multiply by 400 cement, so it is 125.5 only. So to cover that water, I have to increase the cement content. So gradually, let us find out how much more we need. So 465 kg of cement, then we cover the deficiency of the water. Now it's 145.9. For the volume of dry rotted quartz aggregate, it is predetermined from the ACI to be 0.72. However, since I need a pumpable mix at a high slump 175, so I will choose a lower value, which is 0.67. So the air content is 1.5 if that is non-air entrained concrete. Fineness modulus of the sand is equal to 2.6 as determined from this grading. So automatically it will calculate, and it suggests that we are in between this lower limit and upper limit. For the dry rotted quartz aggregate, as you know, it has to be the combination of these two aggregate, and if they were 3, it will be combination of 3. So after calculating the 59% of 19 mm and 41% of 9.5 mm, we reach to a value of 1726 kg per cubic meter. For the mass of quartz aggregate, that will be 1726, the dry rotted bulk density, multiplied by the volume of quartz aggregate, which is the 0.67, as I estimated before or assumed before. So now we get mass of quartz aggregate to be 1156 kg per cubic meter. So since we have the mass of the aggregates, the cement, the water, and probably the admixture, let us assume also, which is 4.5. So we can then get the solid volume of all materials except for the fine, which is the summation of all this volume of the cement, the water, the admixture, the coarse aggregate, and the volume of air content itself, so giving us 0.71. And of course the remaining is 1 minus 0.71. 0.29 is the volume of the sand. So for the mass of coarse aggregate, simply we have to multiply 59% by the total mass of coarse aggregate, 1156, giving us 682 kg for the 19 mm, and for the 10 mm, 41% of 1156, so it is equate to 474 kg. And for the sand or natural sand, simply we have to multiply specific gravity by volume times 1000. The same goes here. For the specific gravity, we have to take it from the third-party test report or internal test report. Also the water absorption, we have to update from your third-party test report or internal also. For the water content of the admixture, ask your admixture supplier, of course. So again, the same thing, summation of all this SSD weight will be our assumed brush density. We can also double check the volume in 1 cubic meter by this formula, only summation, very easy. And I have still here the aggregate to cement ratio as an indication for the workability also. I just include it. And let's move on to the aggregates grading. You all know that we just need to update the grading of aggregates. We have to put the percentage passing of the particle size for each sieve sizes or sieve openings. And this is very basic. You can even ask your technician to provide you. So updating that one, we can double check the coarse aggregate combination. So it's in the limit, and you can go ahead and check one by one also from here. For the fine aggregates, let us check also within the limit, upper and lower limit. In this example, we are required to use 125 mm diameter of pipeline for the pump. So the criteria is 55% mortar volume. The criteria is 52 to 55%. So we get typical, the result is 55%. So we are in the typical value. So again, these are only suggestion and recommendation, although this is coming from the research from different guidebooks, and the combined grading graph coming from the ACI itself, although it's not a specification unless it is mentioned in your project specification. Otherwise, to avoid guesswork, so it really helps us to get into the near value or near fact for the computation of our proportion of the aggregates, so leading us to a good workability based on the ACI recommendation. So here let us use the pumpability curve. The pumpability, so we are above the target line, the red line, so we are pumpable in this case. If we can also check the other combined grading, just to show you the coarseness factor. Of course, we are above the line, the box. We are outside the box because this is actually more on the paving mixture, the use of this combined grading. If you want to create self-compacting concrete, you can also use this typical combined grading graph. And for tarantula curve, same as this on the other side. So So basically you have also this from the advanced template. I'm just repeating the idea how to use it. So again, this is very important. As I mentioned before, the paste plus air over the aggregate voids. Our aim here is to cover that aggregate voids, to lubricate the materials, to coat the aggregates with the cement paste, as repeatedly explained by ACI. So that is the end of our presentation. I hope you get the idea and the value of the template and how to use it. And if you like this, share it to your colleagues and press the like button, subscribe, and leave a comment below if you need to add whatever your opinion, your suggestion. Let us improve this template. Once again, thank you for watching and see you to the next video. Thank you for watching. Bye bye.